516. We have a standard deviation of 1116, and we want less than to check, let's say 325, and compute. The answer has to be 0.05. If it isn't, we are in trouble, and it is.
Very close.
Yes, yes, it will not be perfect because I rounded up, of course. The same thing if we want greater than. Okay, so this time we want, let's say, greater than 707. And if the answer is not close to 0.05, then we are in trouble, because that's what we determined. Now also click here at the top for in between. So if we still have the mean and the standard deviation, and we had between 325 and 707, and what should the answer be? Otherwise, we are in trouble. Anyone?
And it'll be close to 0.9, shouldn't it?
Absolutely, because we determined them correctly. Very good. Yes. Yes. What else we had that would like to look at? Let's say, yes, for x less than, go back to standard. X be less than, we calculated 35. So there was, the mean was 38.72 on a previous example. 38.72, and standard deviation was 3.17, and we wanted to determine less than 35, I believe, was one problem. And the answer we got was 0.1203. 0.1203. And then we had in between 35 and 40. So let's go to in between. Same mean and standard deviation, 35 and 40, and compute. And we obtained the answer. What was it? 0.5365. Let's see what StatCrunch is giving us. 0.5365. Any questions? Any questions? My next question to you is this. Would you like to go back and select problems to work on from your homework? Would you like to us to select other problems? Would you like to go back to the midterm? We have about 20 minutes that I would like to either use for more problems, or go back to the midterm, or I let you choose.
If it's okay, could we do some of the problems from the homework?
Yes, I'm ready. You choose. Yes. But unfortunately, I don't think it will allow you to go to the homework questions before doing the interactive. Maybe it will allow me. But I don't know if it allows you to do that. But yes, please choose any problem you want. Or if you want, I can possibly choose. If it allows me to. I think it allows me to. Yeah.
Yeah, I'm unable to open it until I
yeah. So let me open it myself. Let me see. Preview. Yes, I'm clicking on the preview for 7.2. Okay, so let's choose. You can still see this, right? I'm still sharing with you. Okay, you tell me if this is okay. So the expression z alpha, z sub alpha denotes the z-score with an area of to its right. The expression z alpha denotes the z-score with an area of, I want to do some calculations. Won't allow me now? Okay, we have to answer. So it's alpha to the right. Check answer. Remember that the subscript of the alpha indicates the probability to the right of the score. So in this book is z, and I'm glad I clicked on this. So z alpha is considered to the right of the score, the area. Okay, so I have to correct that. So z sub alpha, the area to the right. Okay. So the expression z alpha denotes the z-score with an area of 1 minus alpha to its left. Okay, so keep that in mind, and thank you. I'm so happy that we clicked on this because you would have asked next time. So this book considers, and we have to change that. So they are saying that this, so z.1, they're referring to this area, not to the left. So P of z greater than 0.1 is the complement, 1 minus 0.5398.
You're still sharing your screen.
Oh, yes, of course. I'm still showing my screen. I forgot. Yes, so it's 1 minus that. It doesn't really matter because you'll see what happens when we divide alpha by 2. Because we are not going to use this. So we're going to use basically in inference, we're going to use this actually. We're not going to use that. So z sub alpha over 2. So 1 minus, so I got 0.4602, and of course it's expected to be lower than 50%, of course. Good, I'm so happy we did that. So let me go back and share again. Good, so it's 1 minus alpha in that case. So area to the right is the alpha, and of course the rest must be 1 minus what we get. Okay, so let's look at other. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean of 0 and a standard deviation of 1. Fine. Find the probability that a given score is less than negative 1.54. So the probability that z is less than negative 1.54. So I'm going to stop sharing so I can show you what I'm doing, which is really nothing but stat distributions in normal CDF from negative infinity to negative 1.54. The mean and the standard deviation are 0 and 1 because we're talking about z-scores. That's why they somehow a 1 got in there. Okay. Good. Left, yes. 0, 1, yes. So I got 0.06178. Now we have to be careful and read carefully and see what they want. I'm sharing again to how many decimals they want. Or they don't even want us to calculate. They just want us to sketch the region. Okay, so it's definitely this. This given score is less than this. It cannot be this. There is no way. And we check the answer. And let's choose something else. You can choose. You can tell me which number and I'll click on it.
6.
6 it is. Oh, I didn't complete. Oh, sorry, I'm sorry. And the probability is round to 4 decimal places. Okay, here is. So we have 4 decimal 0.0618. Where's my keyboard? Here it is. 0.0618. And check the answer. Okay, next question. Moving on. We want to click on 6. Assume the random variable is normally distributed with a mean of 50 and a standard deviation of 7. Compute the probability. Be sure to draw a normal curve, blah, 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 between 34 and 58. Very good. I can use StatCrunch. Let me see, is it still running somewhere in the background? So let me copy the standard deviation. What was it? So mu is 50 and sigma is 7. And we want between 34 and 58. Okay. So where are you, StatCrunch? Where is my StatCrunch? Right here. So I want mean to be 50, standard deviation to be 7. Oops. And between 34 and what was it? 58. So we compute. And the probability is 0.8623. 0.8623. And I go back, where was I? Where was I? Where is it? Where are you? Right here. Okay, so between 34 and 58 with a mean of 50. So it must be this. It's not this. It's not this, of course. Final check. Okay, and then we will enter 4 decimal places. I will enter 0.08623. 0.80, yes. Okay, check the answer. And here it is. Okay. So let's look at 12. Find the z-scores such that the area under the standard curve. Okay, find the z-score such that the area under the standard normal curve to the left is 0.42. Okay, very good. I need to stop sharing for 1 second so I can show you what I need to present first. So left 0.42. And remember, it's z. So the z-scores. So this is 0. 0.42. 0.42. So this would be 1. This would be 0.42. So this is 0.5. So this will be 0.42. Because this has to be this area. This area is 0.5. This area is 0.5. But 0.42 is given as a z-score, not the area. So 0.42 will be, this is between 0 and 1. This is between 0 and 0.5, right? So 0.42. So I need to determine this area. So we go to second in distributions, normal CDF, from negative infinity to 0.42, 0 and 1 as the mean and the standard deviation, and we paste. And we get, of course, it has to be greater than 60%. So the area for Z to be less than 0.42 must be 0.6628, because I think they want 4 decimals. So I'm going to share now. So the z-score is the z-score such that the area to the curve to the left is 0.42. The area under the curve to the left. Hold on. Find the z-score. Ah, it's the inv norm. Sorry, I misinterpreted. So I didn't read it correctly. Find the z-score such that the area under the standard normal curve to the left is 0.42. Okay, I'm stopping to share. I'll come back to it. So it's the area they're giving us. So this is 0, and this is 50%, so then 42% will be this area. And they want us to determine the z-score. Careful, I misread it. So then the z-score is with inv norm. When I have to find the z-score is the inv norm. The left area is 0.42. Mean standard deviation, yes, left, left, left. Just give me the answer. So it's negative 0.2019. And you can always check determining the area from the leftmost point till this number, negative 0.2019. You don't have to, I'm just making a point. And I have to get 0.42. It must be 0.42. It has to be. So we go to, I'll share again. And round to 2 decimal places as needed. So I'm going to write negative 0.20. Negative 0.20. Careful, because we have to be very careful, like I wasn't. Careful, careful. Read the problem before, maybe more than twice, just to make sure we're on the right track. Anything else you would like to choose? This is awesome. I think I'm going to do this moving forward. I really like this. And we can go back to anything you want. So is there anything you would like to see? Yes?
Question 18.
Which one?
18.
18 it is. Let's see what it wants. Complete the following statement. If you are asked to find the 85th percentile, you are being asked to find an area corresponding to a z-score of, no. An area corresponding to a z-score, no. A data value associated with an area of 0.85 to its right, no. A data value associated with an area of 0.85 to its left, yes. Any questions on this? Good pick. Anything else?
$11.
11 it is. Find the indicated z-score shown in the graph to the right. Okay, we have an area of 0.0. My computer is so far away. Correct me if I'm wrong. I see 0.0985, correct?
You got it.
Okay, so with inv norm, please, I'm going to stop sharing. I'm going to write it here. So 0.0985. With inv norm, please, I'm stopping to share. Okay, so we go to second and distributions. With inv norm, area to the left, 0.0985. And it was a z-score, so then 0 and 1, no change there. And we want to find the z-score. And it's negative 1.29. So z equals negative 1.29. Let's see how many decimal digits they want. I think they only want 2. I'm going to share. Round to 2 decimal places as needed. So it's negative 1.29. Negative 1.29, yes. Anything else from here, or we can go back to 7.1?